This catalytic converter did not commit suicide. It was murdered. And the culprit is right in here. Hi, I'm Jim Scopolitis. In today's program, I'll show you how to diagnose a catalytic converter. Is it working or not? And if it isn't working, why not? After all, a catalytic converter is a passive device. It doesn't have any moving parts, so if it's dead, something else has killed it. And you'd better find out what it was, or it may kill the next catalytic converter as well. Basically, a catalytic converter consists of ceramic honeycomb structures coated with a catalyst, a combination of metals such as platinum that speed up chemical changes in the exhaust. These ceramic structures are called monoliths. The ceramic monoliths are housed in a metal shell, and they're supported by a mat which holds the monoliths in place as they warm and cool. Usually, the shell has metal shields crimped onto it as well to protect the vehicle from heat. As you know, exhaust from the engine contains pollutants that could damage the environment. The catalytic converter helps these pollutants change into gases that are safer for the environment. Most of the time, a catalytic converter just sits there, quietly doing its job. But once in a while, a converter fails. When this happens, you'll see one or more of these four symptoms: loss of power, noise, emissions failure, or odor. Problem is, any of these symptoms can be caused by lots of different things, not just a faulty catalytic converter. Take loss of power, for example. Here's a list of possible causes. The list includes everything from fuel system problems to ignition system problems to other things, such as failure of an engine control system sensor, which could lead to a too-rich condition, a problem in the charging system, and a restriction in the exhaust system. And there are a number of things besides a faulty catalytic converter that could restrict the exhaust system. So before you take a converter off, ask yourself, is this converter really dead? The folks at AC Rochester have been looking at catalytic converters replaced under warranty. Here's what they find. 50% of the converters returned under warranty were overheated or over-temperatured. 5% of the converters produced a bad odor. Another 5% were faulty for various other reasons. But 40% of the converters returned under warranty were actually okay. There really was nothing wrong with them. The point is, don't just pull off the catalytic converter if you see one or more of these four symptoms. Do a careful diagnosis first. Loss of power. As with any drivability diagnosis, you start with an onboard diagnostic system check. You'll find the procedure for the OBD system check in Section 6E3A of the service manual. Be sure you're using the correct service manual for the vehicle you're working on and the right 6E3 section for the particular engine. As part of the OBD system check, you check for diagnostic trouble codes, or DTCs. Let's say, in this case, the OBD system is working and there are no codes. Next, take the vehicle on the road to see if you can recreate the problem the customer reported. Let's say you confirm that the engine is losing power, especially under load. Next, you would check for a restriction in the exhaust system by doing the restricted exhaust system check. You'll find the procedure for the restricted exhaust system check in the service manual, Section 6E3B. It's Chart B1. To perform this test, install a back pressure tester, such as the Kent-Moore hose assembly J35314A and the pressure gauge J29658A, or a Burroughs BT8515 or equivalent. With the engine running at operating temperature, measure the exhaust system back pressure. Compare your readings with the specifications in the service manual. If the back pressure is higher than the specifications allow, the exhaust system is restricted. But don't just cut the converter off. Check first for a collapsed pipe, heat distress, or a failed muffler, before you remove the catalytic converter. The second symptom of possible converter failure is noise. If a customer complains about a rattle that seems to be coming from the catalytic converter, again, don't just replace the catalytic converter. Do a complete diagnosis first. Start by verifying the problem. What does the noise sound like? Next, check out the other possible sources of the noise. You'll find a list of them in the reference guide that comes with this videotape. In the reference guide, there's a catalytic converter fault tree. This table will help you diagnose the problem when you suspect the catalytic converter could be faulty. It's organized by the four main symptoms: loss of power, noise, odor, and emissions failure. Under noise, you'll find the three kinds of noises that can involve the catalytic converter: rattles, pinging or popping, and leaking sounds from the exhaust. As you can see from this table, there are a lot of things that can cause a rattle that seems to be coming from the catalytic converter. Rattles can come from loose shields, loose joints, a broken monolith, misalignment of the exhaust system, resonant frequencies, and other things, such as a loose oxygen sensor or a loose underbody heat shield. Except for a broken monolith, the fix doesn't require replacing the catalytic converter. So be sure to rule out these other possibilities before you replace a catalytic converter to fix a rattle. Okay, we're down to the last two of the four symptoms of possible converter failure: failed emissions test or odor. As with any drivability problem, you start with an OBD system check and see if there are any DTCs. For an odor, you should check for yourself. How bad is the smell? This can be done at idle in the service bay, or you can take the car for a short road test to try to duplicate the customer's complaint. Naturally, if you have a diagnostic trouble code, you would use the DTC charts in section 6E3A to diagnose the problem. But if there are no DTCs, you should advise the customer to try changing brands of unleaded gasoline. If this doesn't work, put a new catalytic converter on and see if the problem goes away. Does the vehicle pass the emissions test? Does the odor disappear? If it does, you fix the problem. But if not, continue your diagnosis with the list of possible causes in section 6E3B, excessive exhaust emissions or odors. The list of possible causes includes everything from the cooling system to the ignition system, and even lead contamination of the catalytic converter. Believe it or not, that still happens. Some aftermarket octane boosters contain lead. If any of your customers uses an aftermarket octane booster, tell them to stop. Basically, there are two major causes of catalytic converter failure: over temperature and contamination or poisoning. When a catalytic converter is damaged by over temperature, the symptom can be power loss, noise, or emissions failure, or all three. On the other hand, when a converter is poisoned, the symptom is just emissions failure. Of these two immediate causes, over temperature is much more common. When the engine and the catalytic converter are cold, the catalytic converter doesn't function. But when the temperature inside the converter reaches 660 degrees Fahrenheit, it begins to work at 50% efficiency. The catalytic converter works best when its temperature is between 930 degrees and 1380 degrees. The PCM is designed to maintain the fuel-air mixture to keep the catalytic converter within this range under normal conditions. The maximum temperature the catalytic converter can stand for long periods of time is about 1470 degrees. It can also withstand a temperature of 1600 degrees, but only for a very short period of time. At 2190 degrees, the ceramic monoliths melt. but the catalytic converter is cooked long before it gets that hot. You know a catalytic converter is cooked when you can shake it and hear it rattle. When a catalytic converter fails, over-temperature is usually involved. Once in a while, though, you may find a catalytic converter that is poisoned. Poisoning is usually the result of chemical contamination in the fuel or oil. What happens is the platinum and other metals, which speed up chemical changes in the exhaust, get covered with gunk. Then they don't work very well. Using contaminated fuel can cause all sorts of problems: poisoned catalytic converters, poisoned oxygen sensors, drivability problems, and so forth. Okay, you've replaced the catalytic converter and the problem, let's say it was loss of power, goes away. The job is done, right? Wrong. A catalytic converter is like a big, expensive fuse. It burns up when something is wrong in there. It's your job to find out the root cause. The first place to start is with the vehicle's service history. The service consultant should ask, has any work been done on the vehicle recently to correct a drivability problem? Look at your retail facility's service records for the vehicle. Are there any recent repair orders for drivability work for this vehicle? For example, let's say a car with a 4-cylinder engine is in for a loss of power. You look through the old repair orders for the car and find that it was in for misfire 2 months before. The technician found a loose spark plug wire and replaced the wires. That fixed the misfire. Now, 2 months later, the car is back in for loss of power, and you find the catalytic converter is cooked. Is there a connection? Probably. The root cause of the catalytic converter failure is likely to be that spark plug wire that was loose. On the other hand, if you don't find anything in the vehicle's recent service history that you suspect could have killed the catalytic converter, you'd better do some detective work. Is the engine running okay? With a 6-cylinder engine, for example, you can sometimes have one cylinder misfiring and the customer may never notice it. Occasionally, a catalytic converter failure can even be caused by an intermittent drivability problem. To help you do a thorough diagnosis, AC Rochester has put together a catalytic converter fault tree. It's in your reference guide. To use the catalytic converter fault tree, first look under the symptom you're troubleshooting, in this case, power loss. Next, look under the first level for power loss. Here, the table asks you to decide whether the restricted exhaust system condition, resulting from over-temperature, is caused by the normal operation of the engine, which sometimes happens, or a malfunction in the engine control system. Let's take the case of this 6-cylinder engine. As you accelerate to pass another car, you notice a slight miss in one of the cylinders. This helps you get to the second level on the table, where you can narrow the possibilities down to incorrect ignition. At this point, you would probably use your tech line equipment to check the engine. If you did, you'd find out fairly quickly which cylinder was misfiring and why. The point is, you're not finished until you've found the root cause of the converter failure and fixed it. When it comes to catalytic converters, remember, they don't commit suicide, they are murdered. Your job is to track down the perpetrator and make sure it doesn't happen again. See you next time.